Hey there, and welcome to today's Explainer. Today, we're going to be diving into a fascinating topic, how we actually map nature's hidden value. We so often appreciate the beauty of the world around us, but we rarely stop to think about how to actually measure or locate the exact benefits it provides to us. Well, that's exactly what the spatial analysis of ecosystem services is all about.
Think about this for a second. How do you put a value on a sunset, or a lush green forest, or a perfectly clean river? It feels almost impossible, right? These things seem abstract, almost invisible when it comes to hard economics or civic planning. But here's a reality check. If we can't quantify and map these invisible benefits of the natural world, we really can't protect them or use them sustainably.
So here's our roadmap for this explainer. 1. Mapping nature's hidden value. 2. Provisioning our basic needs. 3. Regulating and cultural services. 4. Drivers of ecosystem change. And finally, 5. Designing a sustainable future. Okay, let's just dive right into this.
Section 1. Mapping nature's hidden value. So what exactly are we talking about here? Basically, spatial analysis of ecosystem services is the study and mapping of how ecosystems provide benefits to humans across different locations. Think of it like a special lens. It takes all those invisible, vital services that nature works so hard to provide and makes them literally visible on a map. This whole process involves identifying, quantifying, and eventually valuing these areas so we can support way better decision-making. And what's really wild is how we take this super abstract ecological data and transform it into concrete, color-coded maps. You've got water bodies popping in blue, vegetation cover marked in green, and built-up urban areas in red. By plotting these out geographically, scientists and city planners aren't just staring at boring spreadsheets anymore. They're looking at a completely dynamic, living representation of our resources. Okay, but how do we actually build these things? Well, we evaluate spatial function using 3 main steps. First up, indicators and metrics. This means assessing the actual health of a landscape by looking at stuff like species richness, habitat connectivity, or water quality. Second is the spatial analysis itself, where we bring in the high-tech tools, things like Geographic Information Systems, or GIS, and remote sensing technologies to track patterns. And third, we use ecological modeling. This is where we use computer models to simulate landscape processes and actually predict future changes. That's the heavy technological lifting that makes all this possible. Moving right along to Section 2, provisioning our basic needs. When mapping out these different land uses, I want you to connect it directly to your own daily routine. The green forested areas, the agricultural patches, the bodies of water, they aren't just geographic features. This is literally the food sitting on your dinner table. It's the lumber used to build the roof over your head and the clean water flowing right out of your kitchen tap. Nature really is our ultimate provider. We usually break these direct provisions down into 3 key areas. First, food production. Spatial analysis helps us pinpoint areas with the highest agricultural potential, which means we can optimize our food yield while keeping environmental harm to an absolute minimum. Second, timber harvesting. Mapping out forest resources means we can harvest wood sustainably, making sure the forest stays healthy and biodiverse for the long haul. And third, water supply. Analyzing where our water is, along with its quality, is absolutely crucial for managing such a finite resource. Because if we know exactly where these services happen, we can extract what we need without destroying the underlying ecosystem. Now for Section 3, regulating and cultural services. All right, let's look at the regulating side of things first. These are essentially the silent, background systems working 24/7 to keep our planet livable. Number 1 is climate regulation. Mapping helps us find areas with high carbon sequestration capacity, which is totally vital for mitigating climate change. Number 2 is water purification. By assessing how well watersheds filter water naturally, we can guide resource management and pollution control. And number 3 is natural disaster mitigation. By identifying areas prone to high flood risk or severe erosion, this mapping quite literally protects our homes. It's like nature's built-in safety net. And that brings us to the other side of the coin, cultural services. We're not just looking for timber to harvest, we're pinpointing places for recreation, scenic beauty, and cultural significance. It captures that amazing aesthetic joy you get from your favorite hiking trail or a historical site. Now, these benefits might be harder to slap a strict price tag on, but let's be real, they are incredibly essential for our well-being. Specifically, we're tracking 3 things here. First, recreation, which supports tourism and outdoor activities while making sure we don't accidentally trample the ecosystems we're enjoying. Second, aesthetic value, mapping scenic landscapes to preserve the natural beauty that enriches our lives. And third, cultural heritage,
Identifying these spots on a map ensures that places of deep cultural significance and traditional knowledge are protected. Once it's officially on the map, it can't be easily overlooked or just paved over by new development. Section 4. Drivers of Ecosystem Change.
So, what are the pressures threatening all this? There are 5 major drivers, literally reshaping our ecosystems right now. We have climate change, bringing rising temperatures, altered precipitation, and extreme weather. There's land use change, where natural habitats are rapidly converted for urbanization and agriculture. We face relentless pollution of our air, water, and soil, which degrades ecosystem services and kills off biodiversity. We've got booming population growth, putting unprecedented pressure on natural resources. And finally, overexploitation. Think overfishing, hunting, and unsustainable farming practices. All of these threats are compounding urgently, which makes knowing exactly where to intervene incredibly critical.
Which brings us to our final part, Section 5, Designing a Sustainable Future. Let's see how all of this builds into actual practical solutions. We've seen the value, we know the threats, so what do we actually do with the data? Well, the spatial data we've been talking about forms the backbone of 3 crucial pillars for decision-making. First up is land use planning. Armed with these maps, planners can make sure human development meets our needs while rigorously preserving those essential ecosystem services. Second is conservation strategies. By identifying high-value areas, we can prioritize conservation efforts and optimize exactly where we spend our limited resources. And third is policy development. Instead of just guessing, policymakers can use this hard, spatial evidence to craft sustainable, scientifically backed decisions. It's a real game changer. The really crucial point here is that this kind of mapping guides sustainability across completely different environments. In growing cities, sustainable urban planning uses spatial data to minimize environmental impact and promote green infrastructure, like urban parks. Conversely, out in rural areas, sustainable agricultural practices rely on the exact same kind of data to reduce soil erosion, conserve water, and enhance biodiversity on farms. Meanwhile, we're also mapping out protected areas to preserve untouched biodiversity. So whether it's a concrete jungle or a massive farming community, spatial analysis provides the blueprint. To tie this whole shebang together into a working framework, we can look at the Pressure State Response, or PSR cycle. This was developed back in the 1970s by a Canadian statistician named Anthony Freed, and you can think of it as the ultimate cheat sheet for environmental problem solving. It works like this. Human activities create a pressure on the environment. This changes the state or health of the ecosystem. In turn, society has to formulate a response, like the policies and conservation strategies we just discussed, to alleviate that original pressure. Sure, it's a bit of an oversimplified model, but it provides a very strong logical basis for understanding how we must interact with our environment. Which leads me to a final thought for this explainer. Think about your own life, your own hometown. Knowing what you know now about the invisible services nature provides and the very visible threats it faces, how will your local community respond to the environmental pressures it faces today? The tools are there, the maps can be drawn, but the response? Well, that's entirely up to us. I really hope this deep dive sparked your curiosity to look a little closer at the landscapes around you. Thanks so much for joining me, and keep exploring.